What is a heartbreak star? Well, it's not a star that broke your heart by cheating on you with another star. No, it's much worse than that. It's a star that breaks its own heart by creating massive waves of plasma that crash into its surface and explode with the force of hundreds of nuclear bombs. Sounds pretty crazy, but it's real, and it's happening right now in a galaxy far, far away. This star is a part of a binary star system called Macho 80.7443.7718. Which is a mouthful, I know. So for the sake of our sanity, let's just call it Macho for the rest of the video. Macho is located 169,000 light years away from Earth. That means if you could travel at the speed of light, which you can't, it would take you 169,000 years to get there. That's longer than the entire history of human civilization. So yeah, it's pretty far. But what makes this star so special? Well, it has a very clingy companion that orbits around it every 32.8 days. This companion is so close that its gravity squeezes and squishes the star into an oval shape, making it look like a beating heart. How cute, right? Wrong. The companion also steals material from the star's surface and drags it around at supersonic speeds, forming huge waves that are 3 times taller than our sun. Imagine a tsunami wave that could swallow up our entire solar system. Yeah, I think I'll skip that, thank you very much. These waves aren't exactly giving the star a gentle massage. They're more like cosmic bullies, hitting the star's surface like it owes them money. And guess what? The star doesn't just sit there and take it like a champ. No way. It strikes back with awesome explosions of energy, shining like it's putting on fireworks display for the whole galaxy. Normally, heartbeat stars do a little light dance, changing their brightness by barely 0.1%. But hey, there's always an outlier, right? In this case, we have Macho. Macho has always been different. This star isn't satisfied with the norm. Every 32.8 days, it becomes much brighter, showing a 20% increase, which is 200 times more than the fluctuations of typical heartbeat stars. That's like going from a flickering candle to a gigantic spotlight in the blink of an eye. And not only that, but it's also getting so hot and bothered. We're talking temperatures hotter than the core of our sun. But how did we figure out what's going on in this star system? How can we analyze the waves and the explosions on a star that's so far away from us? Well, because of 2 astrophysicists from Harvard, Morgan McLeod and Avi Loeb. It is easier now. Why? Because they applied the existing computer modeling of gas dynamics on Macho's surface. They calculated how the gas moves and changes when the waves and the explosions hit it. They found out that Macho is not just a heartbeat star, but a heartbreak star. But hold on, where does this heartbeat come from, and why do we call Macho also a heartbreak star instead of just heartbeat? Well, besides the fact that we mentioned earlier, which is that Macho's brightness is 200 times more than a typical heartbeat star, there's another reason. It's because the waves are not just regular waves. They are like cosmic tsunamis, huge and full of energy. So Macho's heart doesn't just skip a beat, it breaks and erupts with a lot of force. According to astrophysicist Morgan McLeod, each crash of the star's towering tidal waves releases enough energy to disintegrate our entire planet several hundred times over. It looks like Macho's heartbreak is on a whole different level than ours. He's facing the drama on a cosmic level. But how big are these cosmic waves, you may ask? Well, let me tell you. They rise about 4 million kilometers or 2.5 million miles above the primary star's surface. That's like stacking 333 Earths on top of each other, and they form when the companion star gets too close for comfort, reaching the nearest point in its 32.8-day orbit around the primary star. Speaking of giants, the primary star has a radius 24 times larger than our sun. Imagine a ball that big in your backyard. Actually, don't. It would burn everything to a crisp. The outer layers of this bloated star are thin and loose, making it easy for the companion star's gravity to pull and stretch them. Well, these waves are more like freaky monsters that defy the laws of physics. They are upside down with a dip at the front and a peak at the back. Why? Because they have to keep spinning around the star without losing their speed or direction. And when they reach their highest point, they can't hold it together anymore. They break apart and splash all over the place, creating a hot mess of gas and plasma. This mess forms a ring around the primary star, like a giant donut of doom. And every time the companion star comes around, it smashes through the ring and destroys it, only to see it rebuilt by the next wave. The ring also is spinning very fast, much faster than the primary star itself. It takes only 4.4 days for it to complete one rotation, which is how often we see the star's brightness change. But wait, there's more. This star is not only breaking apart because of its waves and ring, it is also breaking apart because of its own internal processes. You see, this star is very young and impatient. It is only 6 million years old, which is like a baby in star terms. But it is already burning through its fuel like there is no tomorrow. It will explode as a supernova in a few million years, which is like a teenager in star terms. That's very fast for a star. And as it burns through its fuel, it changes its composition and structure dramatically. It has stopped burning hydrogen in its core, which is the simplest and most common fuel for stars. Instead, it has moved on to burning helium, which is harder and less efficient. But that's not enough for this star. It keeps switching its fuel every time it runs out of one element, going from helium to carbon, then to oxygen, then to neon, then to silicon, until it reaches iron. That's like changing your diet every week, from fruits to vegetables, then to meat, then to cheese, then to bread, until you reach rocks. Yeah, that is not healthy. And as it changes its fuel, it also changes its size and shape. It has expanded its outer layers by 2 or 3 times, making it easier for the companion star to mess with it. The companion star's gravity pulls on the outer layers more strongly, creating bigger and bigger waves every time it passes by, getting closer to its own death. But a star like this doesn't go quietly. It goes out with a bang, a big bang, a supernova explosion that will blow up the star and everything around it, including its clingy companion. That's right, the heartbreak star is doomed to destroy its own partner in a final act of cosmic revenge. How's that for a plot twist? Talk about a toxic relationship. So what can we learn from the heartbreak star? Well, for one thing, we can learn that sometimes love hurts, literally, especially when your lover is a giant ball of gas that steals your stuff and makes you explode. But let's not dwell on the negative side of things. Let's focus on the positive side, like how awesome our channel is and how much you enjoy our videos. Well, we hope so. After all, they say confidence can move mountains, right? Or was that just a motivational poster in my dentist's waiting room? Anyway, I hope you enjoyed this video and learned something new. If you did, please give it a thumbs up and subscribe to our channel for more awesome content like this. Don't forget to leave a comment below and tell us what you think of this star system. And remember, if you ever find yourself in a bad relationship, don't be like the heartbreak star. Don't explode and take your partner down with you. Just break up and move on. Trust me, it's better for everyone.